All right, so today we'll continue looking at unit circle trig. So we're still same section as yesterday, just part 2. All right, so yesterday we looked at the unit circle, and you were able to figure out the coordinates for the 4 quadrantal angles. Just as a reminder, let's go through those. And Peter, can you give me the coordinate that 0 degrees would go to?
That would be 1, 0.
Yep, 1, 0. How about Paige? Can you give me the one for 90? 0, 1. Very good. Alex, can you give me the coordinate for 180?
Negative 1, 0.
Negative 1, 0. And Robin, what about the coordinate for 270? 0, negative 1. So if you notice, all those coordinates, because they're on an axis, they all have a 0 in them somewhere. And they all have a 1 or negative 1. Okay, those are the easiest coordinates to work with. Arithmetic is pretty straightforward. Just as a reminder, what do you get when you do a number divided by 0? Yep. Undefined. So some of the trig functions will come out undefined when you use these coordinates because you might end up with 0 in the bottom. What about if you have 0 divided by a number? Assuming it's a number that's not 0, not 0 divided by 0. That's different. Yep.
It would just end up being 0.
It would end up being 0. Yep. Okay, so we went through that, and then we also went through the 6 definitions of the trig functions. Okay, the sine, the cosine, the tangent, the cosecant, secant, cotangent. Okay, so we still need to know those for today. Okay, any questions on anything I just mentioned? Those coordinates, the definitions of those 6 functions, things like that. Okay, what about if you have an angle that's too big? What can you do with an angle that's too big to make it smaller? And then how much smaller do we want it to be? Because we don't want it to be too small. But, yeah, Victoria?
Subtract 360 until it's under 360.
Yeah, subtract 360 till it's under 360, but more than 0. So somewhere between 0 and 360. 0 is fine. Now that's if it's too big. What if it's too small? What can you do, Ashlyn?
You do the reverse of it, which is you add 360 until it's in that spot that you want it to be.
Yep. So if you've got an angle too small, we can add 360 to it to get it to be something that's easier to work with. And we go from there. Okay, so we'll probably we'll see that maybe a little bit today again and more tomorrow. All right, so what we're going to look at today is how we can find the 6 trig functions, but we're going to work with the 3 specific angles I have on the board: 30, 45, and 60. Now, once we learn how to figure out the coordinates for those angles, you're going to recognize some of them. Okay, you've already seen some of them yesterday. I just didn't tell you that's what they were. Okay. All right, so we're going to start off by looking at the 45, 45, 90 right triangle. If you already know it from geometry, that's great. If you don't, that's fine too. We're going to go through it right now. Okay, so I've drawn my unit circle. That's a radius of 1 unit in every direction. If this is 0 degrees, and that's 90, 45 would be about halfway. Any questions why I put 45 where I did? All right, now what I'm going to do, and pretty much every problem we do with a unit circle today and tomorrow, we're going to make a triangle out of that point. So I'm going to draw a line to the origin, and I'm also going to draw a line, close enough, straight down. Right, so I just created a right triangle. And because this part right here is 45 degrees, so is this part. It's a 45-degree angle from the positive x-axis. So 45, 45. Now, one of the sides in that triangle I already know. Somebody tell me which side in that triangle I already know the length of? Yeah, Hayden?
The hypotenuse,
Yeah, how come I know the length of the hypotenuse?
because it matches up with the radius.
Yeah, the hypotenuse in this triangle is the radius of the circle. And what did we just say the radius was? It's 1, okay, because we're on a unit circle. So what I've done, so I've got a little more room, is I drew the same triangle off to the side. So I just have more space to write stuff down. Okay, so this is the origin, which corresponds to that. And then this point is the point on the edge of my circle. Right there. So the goal here is to figure out from the origin how far do you go to the right? That's the x. And then from there, how far up? That's the y. Okay, so we have to figure out the length of those two sides. And once we do that, then we will know the coordinate for 45 degrees. Now, even if we don't know the lengths yet, if you compare the measure of the bottom side and the measurement of the height, how would those two measurements compare? Yeah.
They're the same.
They're the same. Okay, so since they're the same and we don't know what they are, we can represent them with a variable and we can use the same variable because we know they're the same. Okay, it's an isosceles triangle. Okay, any questions on that? All right, so now all I want to do is solve for x. So is there a theorem or a formula that we already know about right triangles that if you plug in the sides, you can figure out how long they are? Yeah? Yeah, we're going to plug all that into the Pythagorean theorem. Could you tell me, plugging in 1 for the hypotenuse and x for the legs, what it would look like when you fill it all in?
It'd be 1 squared equals x squared plus x squared.
Yep. 1 squared equals x squared plus x squared. Just wanted a little more space, but hold on. Questions on that part? Right. Now, Connor, if I combine my like terms, how many x squareds do I have? 2. So I've got 1 squared is 1 equals 2x squared. All right. How about Emily? What would be my next step to continue getting x by itself?
Oh, me, Emily?
Yeah, sorry. Oh, yeah. What would be my next step to get x by itself? Yep, divide by 2. Divide by 2. Okay, I'm just going to go over here because I'm kind of running out of space. So I get 1/2 equals x squared. But now I just want x. So Irene, how would I get rid of that square?
Get the square root.
Yep, we're going to take the square root. So take the square root, take the square root. On the right-hand side, the square and the square root cancel. Okay, on the left-hand side, what you want to do is to take the square root of a fraction, you take the square root of the top and the square root of the bottom, separate. So Cameron, what's the square root of the top?
1.
1. And can we take the square root of the bottom and get a nice answer?
Not really.
No. So that's how long the side is. It's 1 divided by the square root of 2. Now, the only problem with leaving the length like that is what? Yeah?
You can't have square root in the denominator.
Yeah, we just don't want to leave the square root in the denominator. Okay, so the algebra part of this is done. We know how long the side is. We just want to write it a little nicer now. So Alex, how would I fix that so it looks a little nicer?
Multiply both sides by the square root of 2 top on.
Yeah.
Oh, sorry.
No, I gotta remember that. So yeah, multiply the top and the bottom by the square root of 2. So I'll just kind of do this over here. Root 2, root 2, and I'll put my final answer right there. Emily, what do I get for my final answer?
Square root 2
Yep,
over 2.
perfect. That's how long the bottom side is, and that's how long the height is. So to get from this point to that point, we know that this side is x, and x is that long. It's the square root of 2 over 2. Now, to get from this point up to that point, that's also x, which is the same number, square root 2 over 2. So now I just want to write that as a coordinate. So Ryan, could you tell me what the coordinate would be to get to that point?
Square root 2 over 2. And then this is square root of 2 over 2 again.
Yep, square root of 2 over 2 again. So that's the coordinate that you want to know for a 45-degree angle. And we're not going to get into it today too much, but that coordinate is going to work for any 45-degree angle. Right? So let's say you were over here. That's 135. And you draw your triangle on that side. How does that triangle I drew on the left compare to the one on the right? Like geometrically, how would you describe it? It's a mirror image. And when you reflect something or do a mirror image, does it change lengths? No. The lengths stay exactly the same. What's the only thing that would happen if you did it in quadrant 2? One of the lengths would be negative. So once you know that square root 2 over 2, square root 2 over 2 is the coordinate for 45, you can do the triangle, the 45-degree triangle, in any quadrant, okay? Just by reflecting it. Okay? We're not going to get into reflecting it today. That's what we're going to look at tomorrow. Okay? But any questions on that? All right, so we're going to focus just on quadrant 1 for today. So let's find the 6 trig functions of 45 degrees. So Faith, anytime I want to do unit circle trig, it's great that they gave me the angle, but I really need the, I've got to have the coordinate for that angle. So the first thing I would do if I wasn't sure is I'd make a sketch. I'd put 45, and then I'd try to remember what the coordinate is. Okay, you've got to memorize that. It's root 2 over 2, root 2 over 2. Does anybody remember that problem from yesterday? Yeah, we did this one. We already went through, if you look back in your notes, I think it was example 2, I think. I gave you the coordinate root 2 over 2, root 2 over 2, and we went through all the answers. We can go through them again. But the only extra step in this problem is you had to figure out the coordinate for 45 degrees first. Okay. Anybody who looked back, was it example 2? It was, yep. Okay. All right, well, we'll go through it again. All right, so we'll start off with sine. Matt, what would be the sine of 45? And which one did you pick, just so I...
Y.
No, yep, sine is the y. Okay, so we got to be careful. Katie, what about the cosine? It's root 2 over 2. Ryan, what about the tangent?
Tangent is going to be y over x.
Yep, and since y and x are the same, when you divide two things that are the same, you get Just one. Yep. Okay, cosecant. Mason, what's my first, you don't have to give me the final answer, just my first step for cosecant.
You put one over.
Yep, and what do you get when you do that?
Square root 2 over 2.
So we're starting with square root 2 over 2, but we're going to take that and flip it. Yes.
2 over the square root.
That's what I'm looking for. 2 over the square root of 2. And we've seen this one enough times that hopefully you're starting to get good at simplifying this one. Ileana, can you tell me what 2 over the square root of 2 would clean up to?
2 square root 2 over 2.
Yep, it would be 2 square root 2 over 2. And then you can cancel the 2's, because it would be 2 square root 2 over 2. Like that. Rudy, how about the secant of 45?
Okay, so exact thing.
Same exact thing as
That's the
the cosecant. If sine and cosine are the same, so are secant and cosecant. Peter, what about cotangent? Yeah, it would be 1. Okay, there's 2 numbers you can flip and they stay the same. 1 is one of them. -1 is the other one. Okay. Any questions on that? Okay, so again, it literally is the same problem we did yesterday in example 2. All right, so that's the 45, 45, 90. So now let's look at the 30, 60, 90. Okay, when we look at 30 and 60, we can use one triangle to do both those angles. The way I'm going to sketch it is I'm going to put the 30 towards the origin. Okay, so when I draw in my triangle, see if I can squeeze that over. That angle towards the origin, that's going to be my 30. Draw in my fix that, vertical. Close enough. There's my 90. And how do I know that the angle at the top has to be 60? How come, Alex?
When you add 19, 30, you get 120 in that, but one of these not 60.
Right, all the angles in a triangle have to add up to 180. Okay, so again, I've drawn the same triangle off to the side, just a little bigger so I got some space to work with it. All right, so now I want to look at that triangle, and I'm going to ask the same questions I did before about the 45, 45, 90. Irene, is there any side that I already know?
Do you know the hypotenuse?
Yeah, how long is the hypotenuse?
The radius?
The radius, which is? It's 1, because we're working on a unit circle. Now, we're going to use that to help us, but directly, it doesn't give us the x and y coordinate. Now, can I use the same letter for both sides in this triangle? What do you think? Yeah, how come we can't?
Because one length is low on either.
Yeah, we don't have an isosceles triangle. We have a scalene triangle. All the angles are different. All the sides are different. So if I was going to label these sides right now with variables, I'd have to call one x and one y. But the problem with that is now you have 2 variables. And if you plug it all into the Pythagorean theorem, you would basically just have this. Well, you can't solve that because you're missing 2 things at the same time. So that's not going to work. Okay, we're still going to have to use Pythagorean theorem, but we've got to be a little clever about figuring out one of these other sides first. And if you already know from geometry, you just know what it is. But if not, there's something you can do here, like a trick, making another copy of this triangle and doing something with it to figure out one of the other sides. Yeah, were you going to say something? No? Ashton?
I'm guessing you would double it
So it has to do with making another copy of it. So I'm just going to start by seeing if I can just highlight the whole thing. And let's go copy and paste it. I want to see if I can group it all together so it stays together. There you go. Anybody have a guess what I'm going to do with that? Yeah? All right, I'm going to flip it. I'm going to flip it that way. That's what I want. And what could I do with that? Like that?
No.
A little lower? Oh, okay, to make a square. I would have to flip it a different way to make it a rectangle, but I'm going to line it up like that. Okay. So, any thoughts about what I just created there? What did I just create there? Yeah.
Equilateral.
Yeah, I created an equilateral. 60, 60, 60. Okay? And what do we know about an equilateral triangle?
Well, same side.
All the sides are the same. So this side is 1. This side is backwards 1. And this side is also 1. From here down to here. Okay, so I need to infer one more thing from that picture. Let's see what else I know. Yeah, Alex?
The right side is half.
Which?
If two of them together is one, wouldn't one of them alone be half?
Yeah, since I just made a copy, we know this side is congruent to this side. And if those two sides are congruent and they total 1, well, the only way two sides can add up to 1 and be the same is if they're each a half. So now we know that this side right here is a half. So what I'm going to do is erase some of the stuff we have there because I don't need that second triangle anymore. You can leave it if you want or just draw it again, but that looks a little messy to me. So I'm just going to label that top side as 1/2. And it comes from that proof we just went through. Any questions on that? So now we know 2 out of 3 of the sides. You can call the third side any letter you want and figure it out. And now you can use Pythagorean theorem. Okay, so you just had to be a little clever about figuring out one of those other sides first. Okay, that's one way I know how to do it, and there might be other ways too. All right, so Eric, if I fill into the Pythagorean theorem, what will I have this time?
1 squared
Yep.
equals 1/2 squared plus x squared.
So 1 squared equals 1/2 squared plus x squared. I'm going to do that out. 1 squared is 1. Paige, what's 1/2 squared? Careful, not double. The half times 1/2. 1/4. Okay, 1/4. Okay, I'm going to bring the 1/4 to the other side. So how about Robin? If I bring that 1/4 over, what would I get? So -1/4 -1/4.
3/4.
3/4. Yep. So we get 3/4 equals x squared. And then my last step is just to take the square root on both sides and do it exactly like we did before. What's nice this time, though, is that the square root in the bottom comes out to a nice answer. You're welcome. What's the square root of 4? 2. So I don't have to worry about dealing with a square root. Square root of 3, can I do anything with that? No, but it's okay to leave it in the top. So there's x. So if I scroll back up, I know that the height of my triangle, or the shorter side, is 1/2. I know that the longer side is root 3/2. So now I can write the coordinate for 30 degrees. Ryan, what do you think the coordinate would be for 30 degrees? And just start with the x value.
Root 3/2.
Yep, starting at the origin. You're going to go to the right, square root 3/2. And Faith, from that point, how far up? Yeah, you're going to go up 1/2. So that's the coordinate for 30 degrees. Square root 3/2, comma 1/2. Remember that 30 degrees is the smaller angle. It's across from the smaller side. 1/2 is about 0.5. It is 0.5. 60 is the bigger angle. It's across from the bigger side. If you take the square root of 3 and divide by 2, it's about 0.86. So square root 3/2 is a little bigger than 1/2.
Wait, can you say that whole thing over again?
So the smallest side is always going to be across from the smallest angle. The bigger side is going to be across from the bigger angle. Square root 3/2 is about 0.86, which is a bigger number than 1/2. So bigger angle across from bigger side, smaller angle across from the smaller side. And that matters because if I put the 60, okay, so let's just go around the circle a little more. Now I'm going to draw my triangle again, but I'm not going to fill everything out because it's going to get a little messy. What's the difference between the triangle that I just drew and the one I had before? How do those two triangles compare? Yeah?
This one's not a right angle.
They did what?
Does it have a right angle?
It does, well, I just didn't want to draw it over the 30. But yeah, we have the right angle. How do they compare? Peter?
60 degrees at the origin instead of the 30.
Okay, the 60 is at the origin now instead of the 30. So if you cut these two triangles out on paper, how would they look if you lined them up? They're the same triangle. Yeah, they're exactly the same triangle. The only thing that switched places was the 30 and the 60. So what do you think that means about the coordinate?
The x and y is swapped.
Yes. That's going to be your 1/2. That's going to be your root 3/2. So 30 and 60 have the same x and y values. They just switch. Because now that's your 30, where before the one at the top was the 60. Okay, they just switch places. But there's no reason to go through the whole thing again because it's the same. It's exactly the same triangle. Okay, so any questions on the coordinate for 60 or for 30? Question?
Like, I don't know how to word it. Like, I don't get how you figure out like which one to go first.
Which one go right between the two? Do you put the
Yeah.
1/2 or the root 3/2? Well, let me show you. So let's say you ask me to find the sine of 30. So what I do is I just estimate about where 30 is. About right there, okay, less than half. And if I draw my triangle, I mean, this isn't perfect, but I can definitely see this is the short side, this is the long side. So there's two numbers to pick from. There's 1/2 root 3 over 2. So the long side, I said earlier, is always which one of those numbers? That's always the root 3 over 2. And the short side, well, that's always your 1/2. So if you draw your triangle and then, somewhat accurately, now I can see that x is the long side, root 3 over 2.
So always do the long side first, basically?
No, not in the bigger number won't always be first. Because remember, the bigger number in this triangle comes second. It's just a matter when you draw the triangle, how it looks. Sometimes the long side could be horizontal. If I do it this way, now the long side is vertical.
Oh, okay.
And I'll do it in a different color. The short side is the horizontal. So when I sketch it, that's how I always do it. Just look at, is the short side horizontal or is the short side vertical? But the short side is always 1/2. You just have to figure out, is it horizontal or vertical?
Okay, thank you.
Yeah. And it's going to work exactly the same. When you draw an angle over in this quadrant, I can tell that's the short side because it looks shorter. That has to be 1/2. That's the long side. It has to be the other number. Now I can tell you that 1/2 is the x, root 3 over 2 is the y. The only thing you got to be careful about in quadrant 2 is you went left. So what kind of number would the 1/2 be if you go left? It would be a negative. So this coordinate would be negative 1/2 root 3 over 2. Again, we're going to get to quadrants 2, 3, and 4 tomorrow, but I'm just trying to show you how you figure out which one is which. Okay. Any other questions on those two coordinates? All right, so there's really 3 numbers from today you need to memorize. Root 2 over 2, root 3 over 2, and 1/2. That's it. Okay? Those are the three numbers you need to know. All right, so let's see if we can find, where is it? Let's see if we can find the problem. Let's find the 6 trig functions for pi over 6. So Cameron, this came up yesterday. Sometimes we had an angle in radians. And what did we usually like to do with that first?
Multiply the 180 over 5.
And what's that going to do?
Turn it into degrees.
Let's turn it into degrees. And do you know what 180 divided by 6 is? 30. Okay. So now we at least have an idea. We're working with a 30-degree angle. Rudy, what's the next thing I have to do in order to do all 6 of these? Right, we got to figure out the coordinate for 30 degrees. So I'm going to make a sketch. I already have an idea in my head what 2 numbers it's going to be, but I have to figure out the order. Hello, Alex. What are the 2 numbers that we should be thinking of right now?
Root 3 over 2 and 1/2.
Root 3 over 2 and 1/2. We just have to figure out which one goes in the first spot or the second spot. So if I put my 30 right there, make my triangle, I can tell this time that the horizontal is the long side. That's root 3 over 2. And the short side, right there, that's my 1/2. Okay, so Victoria, what would be the coordinate for 30 degrees?
It would be square root 3 over 2
Yep,
and 1/2.
at 1/2. So you don't, if you want to memorize that coordinate, then you can just know it and you don't have to worry about the picture. But if you don't want to have to memorize the coordinate, you just draw the picture and look at it and see which side is longer and which side is shorter. Right, so now we'll go through all our values. Okay, Ileana, what would be the sine of pi over 6? Yep, it would be the y value, which is a half. Mason, the cosine? Good, square root of 3 over 2. And the tangent, again, just imagine putting a division sign in right there and dividing the two fractions we have. So Irene, when I divide those, what would cancel out?
The 2's.
Yep, the 2's would cancel, and I'd be left with 1 divided by square root 3. And Connor, how would I fix that?
Multiply by the square root of 3.
Yep, multiply top and bottom by the square root of 3, and what would you get?
1 square root of 3 over 3.
Perfect. 1 square root of 3 over 3. Now, I'm going to come back to this other answer in a little bit, so don't get rid of this 1 over square root of 3. That's going to help us do something faster in a second. All right, cosecant. How about Connor? Cosecant of pi over 6? Or 30 degrees, same thing? Yep, 1 over a half, which means to flip a half, find the reciprocal, which would be 2. Yep. Yeah, 1 over just means flip. Okay, how about the secant of pi over 6? Final answer, all fixed. Yeah?
2 square root of 3 and then over 3.
Perfect. 2 square roots of 3 over 3. And now to do the cotangent, I have a choice. I can either flip 1 over the square root of 3, or I can flip square root 3 over 3. They're equal to each other. They're the same thing. Zach, which one would be better to flip, and how come? The root 3 over 3?
Yeah.
Okay, how come you want to flip that one? Just a guess?
Yeah.
Anyone have a reason why that's the one we should flip? Or if you don't agree, tell me why you don't. Yep,
I'd rather do the one over root 3.
you would. Why?
Because then I don't have to worry about the root at the bottom.
Exactly. If you flip the first one, okay, what's going to happen is you're going to get root 3. It goes to the top, and you're done. If you flip the second one, you're going to get the root 3 in the bottom. You've got to go through the whole process of fixing it, but you're still going to get the same answer. Doesn't matter how you do it, but I think that way's faster. Okay. Any questions on that one? So it's your 6 trig functions for pi over 6 or 30 degrees. All right, why don't you guys try that one. Find the 6 trig functions for 60. So we'll go over that, and then that'll be our last one. All right, so let's go through and see what we got. If you did it correctly, you probably noticed a lot of similar answers to the last problem. And you should, because the coordinate is very similar. Okay, so coordinate for 60 degrees. Katie, what'd you get for the coordinate for 60?
1/2. And then square root of 3 over 2.
Yep. Anybody else get that? 1/2 root 3 over 2? Yep. All right, so now we'll go through it and see what happens. Orion, what'd you get for sine?
For sine, I got the square root of 3 over 2.
Square root 3 over 2. Yep, good. Mason, cosine? 1/2. And Ileana, how about the tangent? Perfect. Okay, the secant, I'll do that one quick because it's easy to flip. 1/2, you just get 2. How about Zach? What do you get when you flip square root 3 over 2? What's the first step? What do you get? 2 over the square root of 3. And then what do you have to multiply top and bottom by to fix it? Perfect. Yep, root 3. So you're going to get 2 times the square root of 3 over 3. Or square root of 9, which is just 3. And Irene, how about the last one? Cotangent of 60.
The square root of 3 over 3.
Yep, square root 3 over 3. So let's just compare this to the previous problem. Okay, so on the left we have the 6 trig functions for 30, and on the right we have the ones for 60. And if you look carefully, the sine and cosine switch places. The secant and cosecant switch places. And the tangent and the cotangent switched places. Okay, so those are what we call cofunctions. All the cofunctions switched places because you switched all the x and y's. We're going to talk more about cofunctions next academic week, not this week. Okay, but that's kind of a little bit of a hint at what's to come with cofunctions. Okay, so any questions on that? Okay. All right, so the homework tonight is going to be a worksheet, okay, which has the first 10 questions on it. And then there's 5 more questions that are not on the worksheet. I just need you to copy those down from the board or just get them on the video later on. Okay?